Welcome to K-Wave 6 Radio, your show for all things positive. Here's your host, Kirk Spencer. Good morning and welcome to K-Wave 6 Radio. This morning we have a special, very special guest, at least for mine. I listen to his videos every day, so it feels like he's more like family than anything else. Ben Davidson will be with us shortly. I have confidence that he will show up because I just got through watching his morning video telling us about the weather, and he advertised the show in his video this morning. So thank you very much, Ben. If you think you know something about the weather and you think that you know enough by listening to radio or TV news or even the internet, weather stations, whatnot, they're only telling you what's going on Earth, and very few, if any, really get into details of why our weather changes are happening. Everybody wants to just relegate it to nothing more than, oh, we are just burning too many fossil fuels, or we're doing this or we're doing that, as if we can really change the weather as greatly as it is being changed. And while I'm not going to say that we don't have some influence on what goes on with the weather, there's far more going on in the world and in our galaxy, or even just our solar system, just stick to something close, that's going on that basically our media sources do not actually tell us. And Ben Davidson is one of those people who does give us that information, and he gives it to us on a daily basis with references to every place that he gets his information from. On top of that, he's a meteorologist, so he has the ability to take this information and make sense of it for all of us. Before I actually found Ben Davidson's Suspicious Observers on the internet, I used to go to some of the places, not by chance, not by all. I didn't go to all of the places that he goes to, but I used to go to ISWA, and there's one out of Japan that gives information, and of course RSOE and the USGS service on earthquakes. I found stuff on volcanoes, and comparatively I am an amateur looking at all of this information. I can draw some of my own conclusions, but I am by no means am I a scientist. So I had to rely on just my own ability to understand some of the stuff, which is okay. But when I found Ben Davidson's Suspicious Observers on the YouTube channel, I came to find out that he puts all of that information together and makes sense out of it from a scientific point of view, which means I can understand it better because of his explanations. So he, with his shows, I call them shows, but with his videos every day that last only usually about from 4 to 6 minutes long, he gives you a lot of knowledge about what's going on, and even some articles that you can use or read to find out more information. He also has his own website, which is called Suspicious Observers, and you can find that at suspiciousobservers.org. Now, for his website, it's spelled observers with an O for the website address, but he spells it with a 0 for observers in YouTube and in other places. But then again, if you look up Suspicious Observers with an O, you find there's a bunch of people that use the same name. So make it a little unusual for everybody else. Anyway, what else do we have here? we did a little update here at K-Wave 6 Radio recently. We've gotten rid of our Thoughts for Growth segments. They were not really going anywhere with that. So we've gotten rid of that, but on occasion, every 1 or 2 weeks, we put up a podcast on Podomatic.com. That's where our uploads go automatically, and about an hour after we've loaded it into Podomatic, it gets shared to iTunes, Stitcher.com, and it gets shared to our RSS feed for our podcast, which you can find all of that information on our homepage at kwave6radio.tk. If you need more information or have any comments or questions, be sure to send them to our contact page. There's an email address there and a form to fill out right there. So if you don't want to copy the address, you can do it from there, and it comes directly to us. Let me see. The other thing is, in the podcast player, the Podomatic podcast player is embedded on our homepage on kwave6radio.tk. And as all of our shows, we do embed a media player in our blog for our live shows, that is. And we give you all that information, and our blog title is What's New. That way you get to know what's going on here at K-Wave 6 Radio. We're going to take a short break and see if we can get a hold of Ben here real quick. And we'll be back roughly in about 2 minutes, unless we get a hold of him very quickly. So hold on just a moment, and we'll be right back. While we connect with our guest, allow me to share some important information. All of our live shows on Blog Talk Radio are archived shortly after the show ends. You can find all archived shows here via the media player in our K-Wave 6 Radio blog, here on Blog Talk Radio, and on iTunes. Approximately 30 days later, this show will be archived in our K-Wave 6 Radio's YouTube channel, which you can access by clicking the YouTube icon on our website at kwave6radio.tk. While you're there, check out our podcast. Every week or two, we upload an interesting podcast which plays on Podomatic.com, iTunes, Stitcher.com, and on our podcast RSS feed. And remember to keep up with all this happening at K-Wave 6 Radio through our blog titled What's New? Now let's return to our show.
One step back and say, there's a better way, there's a better way. Like a tree, rooted in peace, in peace, in peace. There's a better way, in peace, in peace. There's a better way.
There you are. How are you, Ben?
Doing well. After the show, we're going to have to make sure you've got the correct phone number. Good thing I was
Yes,
listening.
indeed. Yeah, I was asking you for your telephone number, but I never got it. So I know you're a busy guy, and Kat's pregnant, and you're doing all that kind of good stuff back at home. So anyway, welcome to the show. I'm glad you made it.
Absolutely.
Let me see. Before we get started, why don't you tell us something about your 8-month trip around the U.S. and Canada? I know you've got some great stories you'd like to share.
Absolutely. Well, I had just recently decided to, go ahead and pull the trigger on what everybody who gets into this type of information, the alternative news, the truther stuff, whatever you want to call it. It's a huge umbrella with thousands of topics. But once you start to get into that, everybody has this sort of dream of being able to sort of leave that corporate world behind, leave the suit behind, stop working for the man, stop making rich people richer kind of thing, and just go out and pursue things that just seem very cool. And so I had just done that, and I had a lot of extra time on my hands, and so I figured I would go around the country and meet these few 100,000 people who have been supporting me for a few years. Turned a 36-foot RV into the Mobile Observatory Project. Gave lots of talks at schools, universities, museums, science centers, planetariums. We had about 75 meet and greet events where the people who watch the show can come and hang out, which is really fantastic because when you're into a lot of these types of topics, you find it often difficult to talk to other people about it because they either have no idea what you're talking about, or they look at you like you're crazy, or they just don't care. But at these places, apart from the initial nervousness that follows everybody to the events, it was wonderful because everybody realized they were amongst friends. You could pretty much ask any question or offer any opinion about just about any one of these topics, and nobody's going to look at you like you're crazy. So they were a lot of fun. We had 41 states, 4 provinces, and the only reason we didn't do more was because my wife got pregnant. She's due in about a month, and so I had to get her home to rest. And like I said on this morning's program this Saturday, I'm sorry we had to head back east so she could rest. But I'm going back out west this Saturday for a nice little leg that includes Denver, San Francisco, Sacramento, and Salt Lake City. So it's been quite a journey, and hopefully it's not done yet. We knew a lot of people who were traveling with little ones, and it's something we're definitely open to.
Sounds good. What were some of the, tell us, what were some of the most memorable spots that you hit, and why?
I can remember being absolutely floored when I was crossing from North Dakota into Montana. The drive across North Dakota is somewhat less than the most exciting thing in the world. It is basically just flatness and corn and high wind advisories for a few hours as you cross the state. But then as soon as you get towards Montana, you start to get these rolling hills, and then you see these unbelievable colors in the background, this striped land, and you're wondering, what on earth is that? You get a little closer, you realize that not only is it beautiful striped land, but you're looking at cliff faces of a canyon. I've been to the Grand Canyon, and I can tell you that Painted Canyon at the border of North Dakota and Montana blows it away. It's so incredible. The name Painted Canyon couldn't be more appropriate. It looks like somebody went and painted that canyon. So that was just incredible. I can tell you the moment where I was scared the most, it was when I was trying to make it from Calgary to Kamloops in one day, going over the Canadian Rockies in the RV. That was utterly terrifying at times. Praying that my brakes were going to work. It's interesting. I'm good friends with Dr. Kong Papu Yen, who makes a living working for NASA's Goddard Space Flight Center, but he also he's a huge electric universe proponent. He and I do a lot of work together on how the sun affects earthquakes and the weather, and getting to see him in Arlington, Virginia was wonderful. And then, of course, my favorite place in the world to go is the desert, the U.S. Southwest. That's pretty much where we ended up.
I used to live in Arizona. I can't say that I really loved it out there. It was nice, but see, I came from the Midwest as well, so I'm used to dark green trees, not just olive green, which is a lighter green. The heat didn't bother me, but the scenery was... The mountains were beautiful, but no trees made it rather uncomfortable. But you're talking about going through Montana and North Dakota. I remember several years ago I was riding my motorcycle through that area, and I was coming back from the West Coast. And it was kind of strange because you're talking about high wind advisories, and the wind was coming out of the north because I was going east. And it had me on a perpetual lean on my motorcycle. It's like I was leaning like maybe 20 degrees to the left just to stay upright. And when I would go underneath a bridge, I would straighten up, and then when I came out from underneath the bridge, I'd have to go back into a lean. It was strange. So, yes, I understand the high wind advisories.
Wow,
Anyway.
that sounds pretty frightening, actually.
Well, it wasn't too bad. It was a constant wind, so it was just kind of weird to ride down a highway instead of going straight. You're on a lean and going about 70 miles an hour because that was the speed limit back then. So, anyway,
I might have slowed down. I don't know. It's just me. Anyway.
Well, I had a heavy bike. What can I say? Yeah. So let's see. Let's start out with some basic questions. I'm going to assume that some of our listeners don't understand some questions, and I would rather ask these questions and have people understand some of the terminology that I know that you're going to use, because you use this in your videos every day. And I'm going to assume that there are some people out there that don't know, and they're probably not too familiar with dictionaries or don't want to go there. So anyway, what is a coronal hole, and how do they cause earthquakes? Actually, let's start with what are coronal holes and the coronal hole stream and the wind that comes from them, if you can start with all that.
Right. Well, the coronal hole is, it's actually the absence of something. The corona is the atmosphere of the sun, and there's a ton of particles. All of the amazing shots that we get to see of our sun in the morning news, those are all satellites that are picking up ions either in the corona, the atmosphere of the sun, or somewhere down to just about the solar surface. And those particles are suspended there by magnetic forces. And so most of the time they're just sort of hovering there, or they're maintained in these currents or these electromagnetic fields that are actually coming in and out of sunspots. But there are some areas of the solar atmosphere or corona where there are absolutely I shouldn't say no particles, but there are there's an enormous deficit of particles there. There's virtually nothing there, and they look black on some of those satellite detectors I'm talking about, because it's looking for these specific ions in the corona, and it's not finding any, and so it registers black, and we call this a coronal hole. Now, the same thing that keeps the other particles basically suspended in the corona around most of the sun is the same thing that ends up clearing a coronal hole of its particles. Most of the magnetic field lines on the sun come in and loop out from the surface. It's relatively close to the sun, to the point where while we're looking at the sun, we can pretty much see the fields. But sometimes those fields do not loop back down to the sun after they poke out of the surface. Sometimes they stream out into space. Some of these are actually magnetic connections from the sun to the planets. In fact, every planet, so far as we can tell, has an electromagnetic portal, NASA calls it. It's an electromagnetic tether, a connection back to the sun, and they all connect back at coronal holes. And so these magnetic fields, they really tend to surge these particles really quickly. And since at the coronal holes, all of the fields don't loop back down to the sun, they stream out into space. All the particles that would have been there get streamed out into space at incredible speeds. This really, bolsters the solar wind when there's a coronal hole that has faced Earth. These faster particles just scream away from the sun. They catch up to slower moving solar wind particles that had been ejected earlier, kind of bunch them up as they're sort of catching up to them one after the other, kind of like snow bunches up on the end of a shovel. And this can create a geomagnetic effect at Earth, much like a coronal mass ejection or a CME, a shockwave explosion from a solar flare. And so these coronal holes do a lot to Earth geomagnetically in terms of producing auroras, creating geomagnetic storms, much the same way that a solar flare and the particles erupted from a solar flare might do. Now, you asked about earthquakes, and where we are right now with this analysis is much like how the ancients were with the movement of the sun. They knew the sun was going to come up after it was dark, and then they knew the sun was going to go across the sky, and then it was going to set. But they also thought that all these things they were seeing up in the sky were alive, and they were jealous and angry at each other and angry at people, and they basically ruled everything in their lives. They understood what was going to happen. They understood a pattern, but they didn't quite know exactly what was going on. The mechanism eluded them. And that's kind of where we are now with the coronal holes. We have seen time and time again that coronal holes are absolutely proliferative of earthquake activity. Every single one of the 8 magnitude earthquakes from the year 2000 up to now had a coronal hole facing Earth during it. We can't really tell before that because the technology wasn't as good and the data is not as complete as well. Furthermore, if you're looking at lower magnitude earthquakes, we have an ebb and flow of 6 magnitude earthquakes where we get about, on average, 3 per week, but we don't usually actually get 3 per week. We'll get 6 one week, 0 the next week, 4 one week, 2 the next week. And we find that the ebb and flow of those 6 magnitude earthquakes tracks the coronal holes as well. Now, why that is, that's a really good question. There are a number of good ideas that get thrown around the community a lot. One is that those electromagnetic fields that stream away from the sun, even if it's not one of the ones that is directly, constantly connecting Earth to the sun, they will stream past the Earth. They will stream past Earth's magnetosphere. They might interact with our magnetic portal, and they could have an effect that way, basically changing the electromagnetic state of Earth in some way. We also know that coronal holes put out something called Alphen waves. Now, I'm not going to get too technical. You can Google Alphen waves if you want, but what it really means is these are a special type of energy that is put out by these coronal holes. And if I can make it as simple as possible, we know for a fact that these waves that come from the coronal holes transfer the sun's energy to the planets far more efficiently than the rest of the sun does. So there's that as well. Last but not least, this is pretty much one of the newer ideas, but it's one that's really making a lot of ground quickly. Most coronal holes come with, like I said, these breaches in the magnetic field structure of the sun. But these breaches in the magnetic field structure of the sun, which make the coronal holes, are not exactly random. It tends to be a wave, up and down, such that we tend to see a positively polarized coronal hole and then a negatively polarized or charged, however you want to say it. And this oscillates back and forth. And as this happens, basically the nature of the solar wind changes electrically, magnetically. And we call this change a sector boundary. And there are a number of individuals who have done a good job correlating these sector boundary crossings with these earthquake upticks as well. Now, in truth, it is often impossible to separate something, it's very difficult to say, well, was that an effect of the sector boundary or was that the coronal hole? Because they often happen very close together time-wise. It's not really as important, the mechanism that will come in time. What's more important is the recognition that there is this pattern that exists and getting it recognized and basically pushing it forward and hopefully one day getting to the point where we can predict an earthquake that will help somebody.
A lot here just by listening to you. Now, let me ask you this question because I'm going to assume, and I don't have anybody to ask this of right now, but can you explain the electric because I know you have this series called The Electric Universe. Explain to us about the electricity. Now, I'm a person I'm a person who knows and understands, and because of my own ability, that there are people out there that don't understand that the energy does exist everywhere and how it works within our system.
Right. Well, that's a very expansive question. The best way I can introduce this topic, and that's really all I can do, is introduce the topic.
Mm-hmm.
Think of Star Wars. Think of the Force. This underlying energy that passes through everyone and everything from one end of the universe to the other. And it can be interacted with. It has power. It can manipulate things. It can change things. And then forget the science fiction aspect. Tweak what Einstein was looking for with the ether out of being a tangible particle that you can measure. And this thing is absolutely real. There is an electric field that goes universally. It's essentially think of little stress balls, the little things you can squeeze, connected to 10 other squeeze balls by little springs, or even maybe a better way to think of it is a slinky. And this goes on all throughout the universe. And what we call this is vacuum energy. It's basically virtual plasma. It's energy we don't really know how to utilize or interact with. We barely know how to detect it. But it's called vacuum energy because even when there's supposedly nothing around in the vacuum, the emptiness of space, it is not actually, in fact, empty. It is full of this potential, this energy potential. And that makes perfect sense. We know that energy is matter. Matter is just really bound up energy in a calmer state. That's E equals mc squared. And so anywhere that there's not matter in this universe, it might seem to us like there is nothing, an empty space, but in truth, there is a phenomenal amount of energy there. And there's actually right now, it's considered one of the greatest problems in physics this day. It's called the vacuum catastrophe, because there is 102 or 112, something like that, orders of magnitude difference between what our standard math says should exist in vacuum energy and that which we are capable of observing. And so the question, of course, we have is, well, do we need to get better at observing this vacuum energy, or do we need to tweak our math a little bit to more reflect reality? That's not a question I'm capable of answering, but what I can tell you is that this is the force. This is that underlying energy that absolutely does connect everything, every atom in this universe. And it's if you look up the Thunderbolts Project, or you look up Walter Russell or Electric Universe, or if you want to know specifically how this relates to our sun, because that's how we're learning the most about it, one of the guys on our crew, his name's Trevor, his YouTube channel is Star Observers, and he's got a bunch of good information on the electric sun and how it might not be this core nuclear fission driven machine. We might want to start favoring some externally driven mechanisms, either wholly or partially responsible for the sun's activity. So that's as best as I could introduce the topic. Any kind of rabbit hole you could want to take in any direction, somebody will have already opened that door for you, and you can just pedal to the metal full speed ahead.
Okay. Before we continue, I just want to remind our listeners that in roughly 45 minutes, Ben and I will be taking phone calls. So if you're at home or at work or wherever you are, and you can make the phone call about 45 minutes, you can call us at area code 347-677-0812 in the United States and Canada. Once again, it's 347-677-0812. Or if you connect with us on the Blog Talk Radio site, you can click on the Skype icon, which you can call from your computer or your smartphone, your tablet, whatever. If you have Skype on there, click on that and follow the prompts to call in, and that will be in roughly 45 minutes. Now, let's continue on with, I have got a lot of questions, and I'm not sure we're going to get through all of them, but let's see what we can do. While you were talking about...
I apologize.
That's okay. That's fine. That's the idea, is to explain it, because I know I can't do it. So, let's see. On occasion, you do talk about, on your daily broadcast, talking about where we get gamma ray radiation from. Tell us a little bit about gamma rays and how that affects us.
Well, I could give you the standard mainstream explanation, but I'd rather give you what I know to be true and the trend that I see the science going, because it is in a perpetual state of change. First of all, you can find gamma energy anywhere from a supernova to an atom of uranium. Radioactive decay, the highest energy electromagnetic waves. These things can be produced in a number of ways. The things that we talk about most on our channel are the gamma ray bursts that we see coming from the galaxy. It's standard thinking that most of the time these are supernova explosions, and actually a lot of times we see these coming from other galaxies. I should have mentioned that they're not all in our galaxy. In fact, we haven't seen one in our galaxy in a while. But so these massive explosions all over space definitely are capable of creating gamma waves. And another thing is, if you get essentially the pole of a very powerful star or a pulsar or whatever it is that the mainstream is calling a black hole. That's another thing. The electric universe has a little different theory on black holes. But for the purpose of this discussion, let's just say black hole. When you have a really powerful star or a black hole or something like that, you get cosmic jets coming out of the polar region. Really, really ultra-fast, ultra-powerful bursts of energy coming out of the poles. And so it's possible that if a pole of one of those superstars or a black hole type of object was facing Earth, we could see some of that gamma radiation as well. Now, most of the time, the answer to what is its effect on us is practically nothing. If we ever got the major gamma ray burst or a huge one, it could destroy our ozone, destroy our atmosphere. It could theoretically create an extinction event. What is much more relevant to our day-to-day lives is the fact that this energy is really just a different form of what we get from the sun. What we get mostly from the sun is a little bit of infrared, some visible spectrum, some ultraviolet, extreme ultraviolet, and some X-ray energy with the solar flares. Well, the gamma energy is literally just the next notch up the list in terms of high energy electromagnetic radiation. And so everything that we've talked about over the past couple of years in terms of humans and electromagnetism tends to be true. Now, we have a full listing of videos and resources explaining this stuff at suspiciousobservers.org, like I said, on the Human Health and Electromagnetism page. But the short version of the story is these cosmic and solar energies seem to be tied to everything from heart attacks, strokes, headaches, seizures, nausea, anxiety, depression, large-scale global peace or revolution, birth rates, infant mortality, pregnancy rates, literally just about anything, crime, traffic accidents, just about anything you could think of is going to be affected by the amount of energy our planet is taking in from outside. This seems like a completely ludicrous thought, to most people who have never thought this way before, because they think, no, I have control of what I do in my daily life, and it's slightly affected by what other people decide to do and this and that and that. To a certain extent, yes, that is absolutely true, but we also have subtle influences that can have not so subtle effects when they are cumulative over time, or when they're done at the perfect moment or in the right way. And we've seen this time and time again. It's really difficult for me to sit here knowing in the back of my head we've got hundreds of top peer review level papers describing some of these things, and what am I supposed to do on the radio? Try to remember the names of them or try to find them and read them to you? No, but if you want to go do some of your own research, this stuff affects us. Even how you feel a certain day could really play a role. There are people who track there are people who have seizures or who have really bad headaches or other conditions, and they track those over time. And they find that when they compare that with data from the sun or data from the galaxy, these gamma ray bursts, there's somewhat of a correlation building. Now, of course, it is very dangerous to start doing this, because if you start watching the solar activity with too much of a mind to saying, okay, I need to watch for when my next headache comes, you could give yourself the placebo effect into having a headache when there's a solar flare or something. So it's kind of 6 of one, half dozen of the other. The placebo effect is very real, and it can go both ways. So it's an interesting topic, but one where there's actually a lot more information than most people think.
Yeah, no, I have a friend who is an astrologer, which I'm going to tell you about in the second hour, because there's something more about him that I think you would be interested in knowing. But even as he said it, or he says it quite often, is that, yes, planetary influences do occur, but is not to say this is the way it's going to be. In other words, if you're a Sagittarius like I am, okay, this is the way your day is going to be. No, this is the way it has the tendency of going, but you still have choice in the matter. So,
Exactly.
Yeah. So, but you got me on a couple of other questions, and I'm going to divert from my list of questions here as I was looking through your videos, and I wanted to get through some of that stuff. But, I live in Mexico, and I live in the Mexico City Valley, okay, which is prone to earthquakes, not as much as California or some other places that you talk about in your daily videos. But we do have these earthquakes. We have the volcanoes nearby. You talk about Colima, which is a few hundred miles away from us, and Popocatépetl, which everybody just calls Popo. It's not doing much of anything. It hasn't been doing much of anything. It's just kind of sitting there, kind of like smoking a cigarette in a lounge chair. So it's not doing anything really dramatic. But every now and then, and I felt one while you were talking, and this is why I wrote it down. I read something, I believe I read it because it was not too awfully long ago, but it wasn't that recent, and I forgot it, where I saw it. And but anyway, somebody had made mention of feeling like there was an earthquake, a gentle earthquake, like a gentle swaying in the ground. But when I go to USGS to find out if there was anything in my area, absolutely nothing. And somebody was actually relating this to the geomagnetic field of Earth changing and having effects from possibly the coronal stream hitting the Earth, whatever. Do you know what I'm talking about? Or if you do, can you explain that?
Yeah, anybody who's ever taken hallucinogens knows what that is. That's the things that happen to your brain when you take mushrooms or you take LSD is a lot of the same things that happen when your brain is subjected to powerful electric or magnetic fields. boy, I wish I had that paper in front of me, because I happen to know there's some glorious sentences in there that are just really perfect. But essentially, everything from, your balance to, the way things you feel or think you feel, or even don't feel, things you think, things you hear, things you see. These things can actually be affected. What otherwise might seem to you as reality might be changed based on magnetic changes. Now, it would strain credulity to think that anything very recently had that much of an effect. But then again, it is possible. None of us know when our magnetic field is going to completely go haywire, because it is weakening very quickly. But before it weakens to zero, it will kind of start sputtering and sort of have a click on, click off moments, and have large breaches here and there, and there'll be many poles that pop up all over the planet. I don't think there's been any evidence that has happened yet. Then again, I'm not going to sit here and tell you it didn't happen, because I know that it's physically possible that it could have had something to do with the magnetic fields of Earth, or, just a local field, something like that. It might not have been the large geomagnetic shell. It might have been something, something more localized. That's tough to say. Completely tough to say.
All right, this is kind of a good lead into where are we going? You have some things about, what is it, 5 reasons why a polar shift is imminent, and you say is confirmed. So tell us about this polar flip for Earth and for the Sun. Are they related? How so? And your indications.
Okay, well, there's virtually no connection. Yeah?
Let me ask you real quick, because I know I'm going to forget this, and I didn't write this down. You were saying in the videos that the North Pole is changing and moving, and in the video that you show, the South Pole is virtually just at a standstill. So you can incorporate all that together if you can.
Absolutely will. Well, first of all, you asked about the Sun, and there's virtually no connection between these two pole reversals. It happens on the Sun every 11 years, so that begins an 11-year cycle at the North. It will be right back there 22 years later, after having been in the South for the second half of that 22-year period. So every 11 years they switch for a full cycle of 22 years. Now, of course, that there's no kind of cyclical disaster on Earth like that. And in general, the pole reversals of the Sun are generally not linked to anything catastrophic here on Earth. Now, the pole shifts on Earth, unfortunately, are related to catastrophic events here on Earth. And I'll basically run down where we are with this situation. So our magnetic poles, and those are different from the geographic poles, by the way. When you think of the North Pole and the South Pole, we think the very top and the very bottom. But the magnetic poles are almost never exactly on opposite sides of the planet, and they're almost never right on the actual geographic poles. They tend to migrate around a fair bit over time, a few kilometers a year this way, a few kilometers a year the other way. But recently, the North Magnetic Pole began speeding up very quickly. The South Magnetic Pole, well, I don't think I would describe it as being at a standstill. It is steadily tracking on a fairly good line, and it actually has left the continent of Antarctica. The South Magnetic Pole is actually not on the continent anymore. It is coming up in the Indian Ocean underneath Australia on a line that looks like it would just miss the southwest part of Australia, which is where Perth is, and places like that. Now, the North Magnetic Pole is racing so fast that at this rate, the notion of this taking hundreds or thousands of years to do a flip has completely gone out the window, because it's going so fast right now that in even just 100 years, this thing would flip multiple times. And so we know it only flips once. And we know that it has been speeding up and speeding up and speeding up. So even if it didn't speed up anymore, if it just kept at this pace, we couldn't have 100 years left. It would have to slow down significantly or change direction, which it hasn't done. And speaking of its direction, the North Magnetic Pole was in Canada for quite a while, but then during this shift, it began shooting northwest, breezed right past the geographic North Pole in the Arctic, and is now actually heading down to lower and lower latitudes towards Siberia. Now, if you can picture this in your head, try to picture a map of the world. One pole coming down through Siberia, it's going to go through China, Mongolia, and come down through Indonesia. South Pole's coming up out of Antarctica, just barely going to miss Australia on the western side, the left side, if you're looking at a map. The poles are heading towards the same location, which is not at all what you'd expect if you can picture the Earth with the North Pole and the South Pole. Now replace the Earth with a clock, so you've got the North Pole up at 12 and the South Pole down at 6. You would think that one pole would, go 12, 1, 2, 3, 4, 5, 6, and the other one would stay on the opposite side of the planet, 6, 7, 8, 9, 10, 11, 12, and they would flip like that. That's what you would think would happen, but that's not what's happening. They're going to the exact same place. And the reason why that's so interesting is because Earth cannot have two poles in the exact same place. The other one would have to be just about on the opposite side of the planet. And if you look at where the opposite side of the planet is from where these poles are going, it looks like it is somewhere in between the Bermuda Triangle and what's known as the South Atlantic Anomaly, which is a huge, weak breach in our magnetic field. It's the weakest protection from energy from space over anywhere in the world. And so it's very interesting that we've got the Bermuda Triangle very, very close to this area, the South Atlantic Anomaly, and it happens to be on the exact opposite side of the planet from the place where both poles are tracking right now. So that's very fascinating. That was 1, 2, and 3 from that video you were talking about. Did you have any questions or anything I didn't hit so far? I was going to do 4 and 5 next.
Well, actually, you're talking about this, and what just went into my mind, and I wrote this note because I didn't know when I was going to get a chance to ask the question. Because I like to listen to whatever you're saying. If the poles coming together, because this is actually relating to something else that I had actually written earlier, but you're talking about the poles coming together, north and south poles, and they're coming towards the same area. They're looking like they're converging in the same area or want to converge in the same area. Is this, or could it be, a relationship to what's going on in the Western Pacific anyway? Because what I'm tying this to is like the movie The Day After Tomorrow with Dennis Quaid, and where all the heat and you have all these hurricanes and cyclones that are coming together and they're cooling down the northern hemisphere. But we know that the Western, well, actually Pacific, but Western Pacific in particular, which is why we get so many, or they get so many cyclones over in that area. It's very hot ocean. So I'm tying this together and trying not to talk too long about this, but the Western Pacific seems to be the hot spot of the world at this point, and as you've talked about it in your videos quite often, is the eastern U.S. is where all the cold spots are. And could this be tied together?
It's very possible. I definitely wouldn't say it's not possible. What I will tell you is that the place where both poles are heading, not only do you have that heat thing, but you've got the Devil's Triangle or the Dragon's Triangle over there, which, if you don't know, the Bermuda Triangle has one of these things on the opposite side of the planet as well. It's called the Devil's Triangle. It's a magnetic anomaly there as well. And not far away from that is actually the strongest part of the magnetic field over Earth, which is actually sitting just about over top of where the South Pole is now, south of Australia. And so you have this area where North and South Pole are set to meet. And it is sitting pretty much right in between the strongest magnetic field protection in the world and the Devil's Triangle. Then on the opposite side of the planet, you basically sit between the Bermuda Triangle and the South Atlantic weak anomaly in the magnetic field. What we have here is a bunch of pieces that clearly have the same colors and shapes, so they're part of the same puzzle. But we're talking about major expert level, and I can't even put the first two together from there. And based on the literature, nobody else can either. This is not something that is really talked about. There is nobody that is denying that the poles are shifting. There is nobody denying that the magnetic field is weakening. They're just not talking about it, and they're not, well, if they're doing the kind of thought exercises and actually trying to figure out the answers like we are right now, they're not publicizing that part of it. So this is what I just told you is basically not disputed, and but it's also kind of a stagnation point. We don't really know what to do, and it's not the kind of thing you can track day by day. It's really only useful to look every couple of years to see how things are doing, because there's so much fluctuation, just night, day, hour to hour, even season to season. So, it's not the kind of thing that you can track every day. But, if everybody is listening to this and they're thinking right now, why should I care? It's because these magnetic reversals on the planet Earth have been linked with extinction events pretty solidly, and a recent study from Berkeley proved that they can happen in as little as 80 years. Most scientists thought that these things took hundreds or thousands of years, which if you were looking at how fast the magnetic pole was moving, 60 or 70 kilometers a year, and speeding up every year, that's not going to take thousands of years to go halfway around the world. But, forget all of that. Berkeley just came out and officially, gave their proper science explanation of why this can happen so quickly. And bear in mind, we're already 100 years into this one, so we are past the minimum time it could happen. This could take another 100 years. It could happen tomorrow. Nobody knows when it could happen.
Mm-hmm.
But this would be the thing that I consider to be the number one most serious issue, naturally, in terms of natural disasters that the world can face right now.
Yeah, I tend to agree. Matter of fact, I didn't know that you the reason why I said the South Pole seemed to be virtually standing still, I was looking at your video and it's like watching the North Pole. And I started watching the North Pole when I was a lot younger. I was actually lucky enough to have a teacher when I was in high school who was telling us North Pole is not actually what we call geo-north. It is actually in Canada. And back when I was in high school, it was lodged right there in north central Canada. And it didn't actually move. And a few years ago, I used to tell people, I said, if you really want to see how the pole is changing, I said, take one of those compasses that are, I used to say plastic compasses. It's clear all the way through. Glue it or stick it to your countertop and just watch the north move.
See, this is where I'm going to tell you that doesn't work.
Okay.
Because the magnetic pole, remember how I told you there's so much fluctuation day to day, month to month, season to season? The magnetic pole makes an 80-mile circle every single day and makes a 350-mile circle every single year, a larger circle, which is why every 6 months you can find people saying, oh, my God, the pole has shifted 170 miles in the last 6 months. We're all about to die. Because that's what it does in every 6 months, and then it spends the next 6 months going back the other way. There's a couple of guys on YouTube who have gotten into, who have basically been calling doom day after doom day after doom day. 2009. It's a brilliant idea, and if you don't know about these circles, that the pole makes, it's really really tough. But I mean, if you actually set it down there, you can see it moving basically hour to hour, day to day. And it's interesting, but you can't track the long-term pole movement that way, unfortunately, because it only gives you one vector. And so if it's on a straight line, it could look like, if it's moving directly away from you, it could be moving really, really quickly, but to you, it would look like it wasn't moving at all. Or, it could be, moving directly 90 degrees, directly perpendicular to a line with you, and it would look like it was going pretty quickly, but it could just be sort of meandering across. Do you understand what I'm saying there?
Yeah, I do, and definitely do. Actually, right now we're going to take a 2-minute break. Give us a little time to get some water or whatever, and we'll be right back. So stay tuned, and about 15, 20 minutes after we get back, we will take calls from anyone who happens to be able to give us a call in. So stay tuned, and we'll be right back in about 2 minutes.
Hi, this is Duke Mayo Rockefeller. Please check out my humanitarian organization, www.livechildlive.org. You are listening to K-Wave 6 Radio with our esteemed radio host, Kirk Spencer.
Thank you for listening to today's show. We'll return to today's program shortly. Keep up with what's new at K-Wave 6 Radio by visiting our website at www.kwave6, that's the number 6, radio.tk. You can subscribe to our blog via the RSS feed button on our blog page titled What's New, or via the social media links in the website. If you missed any of our shows, you can find all of our shows archived in our YouTube channel. The link to our YouTube channel is on the homepage of our website. We also suggest that you check out the programming at Freedom Talk Radio by visiting their website at www.freedomtalkradio.co.uk. Now let's return to today's show.
Hi there. This is Chad C. Meek, writer and executive producer of the epic UFO thriller Giant Rock the Movie. Even if you haven't been abducted by E.T., you need to listen to the K-Wave 6 Radio Network to get the latest of the odd, the unusual, or more importantly, the fun. See you at the movies.
And welcome back to K-Wave 6 Radio. Today my guest is Ben Davidson of Suspicious Observers. If you were here just before the break, now you understand why I have Ben come on to explain things, because here I'm thinking you could put a compass on a tabletop and stick it there and watch the movement of the North Pole, and wrong. Okay, anyway.
To be perfectly fair, the only reason I know is because I've made that mistake before. I couldn't figure out why I was getting different readings than a friend of mine in California. And this is when I was in Columbus, Ohio. So, the angle from Columbus, Ohio to the North Pole versus California to the North Pole is actually significant enough where we were seeing different motions. He was seeing a lot of movement, but the pole was moving almost directly away from me. So even though it was moving, my compass needle didn't really change a whole lot, and I had virtually no movement. And so when I was doing my own experiments, I'm sitting here thinking, man, these guys are all full of crap. The pole's not going anywhere. But I was wrong, and I made that mistake definitively.
Okay. Yeah, coming from the Midwest and the pole was in Canada, yeah, that definitely was weird. Matter of fact, if you heard just the last person on our break, Chad Meek, I was actually going to ask him to be a part of the show, and he was going to be here, but he has to be on the road today, and he'll be out of town for a few days. Chad Meek, because I know you have a friend who has a YouTube channel, and I forgot his YouTube name, Sky something or something like that.
is it Suspect Sky?
Yeah, Suspect Sky, and not too awfully long ago, you guys did a show about UFOs and a few other things. And
Right.
if you know the name George Van Tassel, you ever heard of his name?
No, I haven't.
George Van Tassel was one of the pioneers in UFO studies from the 40s and 50s into the 60s. And as a matter of fact, this is his uncle that we're talking about, Chad Meek's uncle. And he's got a book and a movie that's coming out talking about his experiences with UFOs and whatnot like that. I was going to bring a surprise to you with that and bring him on and your buddy from the video, but I figured, well, one was gone, so I figured I'll do that another time. So now the secret is out, so next time we have you on, we'll just do that kind of a show. Anyhow, let's get back to some questions, because I'd like to continue this, and then if we have any callers or anybody that's in the chat room that wants to send us questions, we can do that. Let's get back to, and I want to tie the two together. I have written these down as two separate questions, but you have a good time explaining them, and I have a great time listening to them. So let's go with this. Tell us about sunspots and magnetic polarization and the filaments that you've been talking about recently, which we seem to be getting a lot of.
Right. Well, think about watching 24 hours worth of Earth satellite, where you see these clouds rolling across the land. And I'm not talking about, a hurricane that basically keeps its form with its eye, although even a hurricane tends to shift its shape and its patterns around a lot, and it spins. But as you're watching clouds go across the United States, for example, you see that, it's not just one shape moving left to right, morph around, they pop up, they fade away, and then they interact with one another. Well, that's a lot like sunspots on the sun. And we know for a fact, because of those detectors that look for ions in the solar corona, the solar atmosphere, that these sunspots we see on the surface of the sun are connected through the corona via these magnetic fields. These magnetic fields that I was talking about before that actually do pop out of the sun and loop back down to the sun, the opposite of the ones that stream out into space for the coronal holes. Well, we're talking about the ones that loop back down into the sun here. Most of those are found at sunspots, and they only ever connect a positive sunspot to a negative sunspot, which makes perfect sense. It's creating the circuit. And there's all this plasma surging through at ridiculously high speeds. Well, now picture that there are these sunspots in a group, and they're moving around and morphing and popping up and decaying just like clouds do. And then think about what's going to happen to all these charged particles in these field loops in the solar corona, the atmosphere, as these sunspots move around just like the clouds do. Well, they're going to interact with one another, and they're going to cross and hit each other and cancel and do all these other things. Well, when that happens, charged material that is moving close to the speed of light in one direction, during one of these crisscrosses or interaction events with another field, can be stopped in its tracks and sent the exact opposite direction at nearly the speed of light. And when you have, that type of deceleration, acceleration to those velocities, you get very high energy. That's the X-ray solar flare I mentioned earlier, and that blasts out particles from the sun in what's called that coronal mass ejection, or CME cloud, that could, hit Earth and create auroras, or at worst even take out satellites, transformers, and power grids.
Mm-hmm.
You mentioned filaments. And filaments pose the exact same danger, except their genesis is nothing like a sunspot whatsoever. Whereas a sunspot can basically have its magnetic fields interact, creating the X-ray energy, which blasts out the charged particles. A plasma filament is basically a tightly packed mass of plasma and charged particles that just hovers over the surface of the sun, again, because of magnetic forces. And because it's not just the sunspots that move around, but the entire magnetic field structure of the sun that moves around, those filaments destabilize as well, and those can erupt. And what's important there is they can erupt with the same force as an eruption from a solar flare, except there is no preceding solar flare. So, for example, when there's a big solar flare and a coronal mass ejection coming at Earth, we see the solar flare hours before we can see the coronal mass ejection coming at Earth, and usually it takes a couple of days to get to Earth after that. But unless you are constantly watching the sun, you might miss a filament eruption at first because there is no flare that would tell you to go look for an erupting filament until at least a while after the filament has already released. Now, this tends not to be that much of a factor because we check in on the sun multiple times a day. We do that official report every single morning, and most coronal mass ejections, whether they're from a sunspot solar flare or from a filament, take 2 to 4 days to get here. It's important, however, because that big one, the one that could take out satellites and fry the electrical grid and basically send Earth back to the Stone Age for hundreds of years, that one could get here in less than a day, maybe as little as a few hours. So filaments are something that we monitor very closely because, at this point, in addition to spending a good deal of my time looking at this data on the computer, I get solar flare alerts on my phone. So when there's a solar flare, I know what happens. But if I'm not looking at the sun and I'm not paying attention, I won't know a filament has released until I either check the data again or, there's a flare a little bit after the fact, which does tend to happen sometimes. However, if the flare is going to take an extra, 45 minutes to an hour to show up, and this is the big one, the big filament, that extra 45 minutes to an hour could be everything in a, pardon my French, shit hits the fan situation, that thing that we all hope never to see, or at least most of us hope never to see. I shouldn't say all of us because, according to the comments, there are quite a few people who would like us to hit the reset button and just start a new game. But for the majority of us, I would like to think, do not want mass destruction and chaos on the planet Earth.
Well, I tell you, sometimes I do cry out, please hit the reset button. But yeah, okay.
I'd love to hit the reset button on the financial system, the way we pollute, the way we modify our foods. The problem is that if you did that right now, there'd be a billion people that died because of it. So we got to find a good transition. Anyway, I've gone off on a tangent. What's your next question, Kirk?
That's okay. I think you might get invited to another show that I'm going to be doing next month. Anyhow, let's see. I've got a few questions here. Let me get back to this one before I move on. We were talking about the movie The Day After Tomorrow with Dennis Quaid, where all there's hurricanes, cyclones, whatever, all around the northern hemisphere of the planet. It was just trying to cool down, like what we see over the Pacific Ocean. Because it is one of the hottest spots on Earth is the Pacific Ocean. So how do you relate that to what we really see versus, movie versus reality?
Well, that's interesting because no matter what kind of brilliant explanation you can come up with, the fact of the matter is everywhere on the planet, the larger the body of water, the more it's going to be affected on its western side by the sun. And so what you have is the Atlantic Ocean. On the east, it's smaller, so it doesn't get as hot, but it still follows the general pattern. The storms basically come off of Africa, race westward just north of the equator and then shoot up the east coast or shoot up into the Gulf of Mexico. Same thing happens on the other side of the planet, except it's a lot warmer. The hurricanes basically start near the equator and then they loop up, or I should have said hurricanes. It's more like typhoons. And most of them end up either curling up towards Japan or they hold true over the Philippines and then they curl up towards Vietnam and China, which would essentially be like the U.S. version of the ones that come through the Gulf of Mexico and up into the Gulf states. We see the same thing reversed in the Indian Ocean. So, for example, in the Atlantic Ocean, the western Atlantic is usually warmer than the eastern Atlantic. The western Pacific is usually warmer than the eastern Pacific. In the southern hemisphere, the eastern Indian Ocean is usually warmer than the western Indian Ocean. And I'm not entirely sure why that is the case. It likely has to do with the ocean gyres and how they work and the direction with which they seem to flow. And by the way, ocean gyres are basically large-scale circulation patterns in our oceans that, essentially, if you were to drop something in the ocean, eventually it would just kind of go around in a large circle. If it didn't get hit by storms or anything else like that, if left to its own natural devices, eventually it would go around in a big circle like it was going into a whirlpool and would end up in the center, which is actually what we've seen in the Pacific Ocean. I don't know if you are familiar with the Pacific Ocean garbage pile, but it is the result of the ocean fire that basically it's a large-scale circulation in the entire Pacific.
It seems to collect somewhere around Midway Island.
Yeah.
Yeah.
Your question is a good one. It's the kind of thing where, man, that's something I'd love to think about, but I'm not sure we could ever even really get an answer to it. I do know that that movie was a bit of a double-edged sword for me because I'm a big proponent of being ready for cold events, just not due to the desalinization of the Atlantic Ocean, per se.
Yeah, well, I'm not going to get really into, their reason why. I have my own theories on that as well, but we can talk about off air another time. But let me ask you this. Let's get back to the realities of what we see on the internet, whether it be Facebook or just by searching somewhere on the internet. There's been a lot of pictures over the past few years about strange cloud formations. That you've traveled the U.S. and I'm quite sure you've seen a lot of them. But how many of these cloud formations are what you would consider to be real versus something that was photoshopped?
Most of the cloud formations that we're seeing are real, especially the new undulatus asperatus clouds. I'll say that again, undulatus asperatus. There are, after basically getting identifying 2 or 3 new types of clouds over the past few decades, we have noticed 3 new types of clouds in just the last 5 years. This is a function of a number of different things. I have seen some Photoshop stuff. All of the Photoshop stuff I've seen is, people trying to create sensationalism, trying to create fear, saying, oh, look, they created this system by combining, HARP, a satellite laser, and, Big Bird, and here's this cloud. Those ones you can usually tell they're pretty Photoshopped and they're fake. But a lot of them are real, and I got to say that this is the kind of thing that we should be expecting to continue happening. If you guys have managed to spell undulatus asperatus correctly and you've put it into Google, you're going to see some clouds that, if you are not constantly watching my channel and watching me update these things, that will make you absolutely drop your jaw. And they are absolutely real as well. Our magnetic field is fading, which changes how energy in space and energy in the Earth interact. But it's more than just that. We have certain levels of our atmosphere that are becoming over-ionized. while I think that pollution has less of an effect on warm versus cold than many scientists, the atmospheric chemistry effect on how storms are formed and how clouds form and what is there for cosmic rays to nucleate into clouds, that all of that stuff is really changing. And so I would have to tell you that the majority of those images you're seeing are real. If it says like, hey guys, I don't know what this is, do you know what this is? There's a better chance of that one being real. Of course, if you see something that is completely foreign to your eyes and they're saying things like, oh, look, they made this to end the world, or, they're doing this and that, you can be pretty sure it's one of the photoshopped ones. But yeah, in short, my answer to you is yes, those are a lot of times very real.
What does that actually translate into us as habitants on this little blue ball floating in space?
Well, that all depends on what we decide to do about it. The best answer is nothing, because what we are seeing now is only unseen for the period of history that modern science is willing to take its cues from. We have all these ancient cultures that, despite the fact that they didn't have text messages or emails, they described with unbelievable accuracy and precision the same things happening in the earth, in the skies, in the clouds, this and that. And even when we can look to our ancient cultures and recognize the brilliance of their math or their architecture or how they were able to track the motions of the planets, we look at their stories of things that took place here on Earth and we completely discard them in mainstream science. And it's ludicrous. It's one of, and I hate to put things so callously, it's one of the dumbest things human beings have ever done, is ignoring the stories of these exact same things, these exact same changes in the sky, in the earth, in the clouds happening. They have stories about this. The Northmen, the Vikings, their stories account the changes in the clouds leaps and bounds, miles and miles better than anybody else. Inuit people track changes in Earth's rotation and our axial tilt. There's a number of different ways that these things are changing. In terms of what it means, back to your question, well, like I said, it all depends on what we do. There is certainly a time of great trouble ahead when it comes to this weather and this climate. There's going to be floods like we've never seen, and droughts like we've never seen, and storms like we've never seen, and blizzards like we've never seen.
Right. Well, you're getting right into one of my next questions. You had that video about the super flood.
Yeah.
And the north shifting in the south, and go right into it, my friend.
Well, absolutely. Noah is not the only person who describes a flood in antiquity. Again, I'm talking about Noah and his ark, not the National Oceanic and Atmospheric Administration. The Sumerians describe it, the Chinese describe it, Aborigines describe it, Native Americans describe it, South Americans describe it. And so I have to believe that there was a worldwide catastrophic flood at some point. Now, the reason why I think that this has to do with the magnetic pole shift is because the things that are supposed to happen above our heads during this magnetic weakening and reversal period are the kind of things that would proliferate massive storms here on Earth. Now, first and foremost, as our protective shield weakens, there's going to be a lot more interaction with energy from space. And so the storms are going to be, for lack of a better phrase, bonkers to begin with. But what is going to happen here is, I'm trying the easiest way to describe this. Okay, the sun is constantly putting out hydrogen, and and this is positively charged. The planets also pump out ions, and for the Earth, this ion is mostly oxygen. And so constantly above our heads there is oxygen release and hydrogen intake. Now, during one of those coronal mass ejections I was talking about before from the sun, somehow, for reasons we do not understand, as that extra large burst of hydrogen is coming at Earth, the Earth releases an extra large burst of oxygen to match it. And in case you're not getting the picture, by the way, that's hydrogen and oxygen, the two components for water set to meet in either the magnetosphere or the ionosphere, which is the perfect electrochemical combination environment. But when you have the magnetic field, that which separates that hydrogen and oxygen is going away. It's weakening. And so you have more hydrogen breaking through. And because you've got more hydrogen breaking through, you've got even more oxygen released from Earth. And you essentially have water production above our heads in a phenomenal way. And this could also explain why when we look underneath the waters, we see cities 50 feet down. Then we see cities 200 feet down. Then we see, more ruins 400 feet down. It's as though the amount of water on this planet comes in these huge surges like that. We call that star water. And that's the premise of the video, super flood.
Okay, before you continue on, and I know you can, and you know you will, I saw the video, and I saw the video where you're having, the oxygen is escaping not only from the north and south poles, but from our equatorial areas. So it's like a great big X, if you will, for the Earth, and the, I would say it was probably the coronal wind or solar wind that's pushing on this and creating this effect that you're talking about. So what you're saying is, correct me if I'm wrong, that even though we're seeing melting of ice caps and all the rest of that, some of what we're experiencing on Earth and have experienced in antiquity was because of this hydrogen mixing with Earth's oxygen and coming back into our atmosphere and causing more water on the planet.
Oh, absolutely. In fact, NASA has officially confirmed this, except for at the planetary level. In fact, they have time and time again on our moon and on asteroids confirmed that it is the sun that is creating the water on these asteroids and on the moon in the lunar soils. Believe it or not, this oxygen that we breathe, which is O2, two oxygen molecules put together, is not the usual way you find oxygen in this universe. It's the way we find oxygen here above the surface of the ground, but even here on the planet Earth, the majority of the oxygen that is making up our planet is not breathable. It is not gas. It is in rock form. It is trapped as either iron oxides or silicon oxides or, other things like that. It's actually in the rock. And NASA's studies prove that hydrogen that the sun pumps out can strike these asteroids and the moon, release that oxygen from its rock bond, and still have enough energy to start creating water. And yet, when the same thing happens at Earth, with the only difference being that at Earth, it doesn't have to be broken out of a rock. Our atmosphere actually releases it free and clear and ready to join with the hydrogen. That's the only difference. It's much easier at Earth. And NASA just hasn't done it because to go away from the cometary water delivery explanation would embarrass dozens of people and basically make millions of dollars worth of their research useless. And so I'm not sure we're ever going to get that. But if I can jump back to something that, something I said a few minutes ago, as scary as this is going to be, we do have stories of it from all over the world, which means people survived it all over the world. And the only thing that could threaten that this time is if humans do something stupid, like geoengineer the planet to the point where it kills us all. I'm going to state this. I'm going to call it as I see it, and I think if you're being honest with yourselves, you can pretty much come down on the same page as this. If you are looking for short-term mitigation of heating, or what they think is global warming, spraying the sky in what they call chemtrails, or solar radiation management, solar sprayed aerosols. If that is your sole goal, is to create these short-term pragmatic mitigation events of global warming, then chemtrails work. However, if it is a goal of yours to not have that reverse into an outrageous warming trend because of all the metal that will then be sitting on the ground rather than reflecting it in the air, and if you wish to be able to grow crops on this planet, and if you wish to not exacerbate things like Alzheimer's or respiratory or endocrine conditions that a lot of the chemicals in geoengineering proposals want to use. If you have all those other goals, then geoengineering is a atrocious idea. Not to mention the fact that human beings don't exactly have science down very well yet. For everything that we have accomplished, I want to give you two facts that should basically, if you have any question whatsoever whether or not you would trust human beings to modify the weather and succeed in a helpful way, assuming you could bring yourself to believe that was their goal in the first place, think about this. We put everything we knew about the universe, science, everything into a computer and tried to simulate the universe. We found out we missed 97% of it. All the world's best science, billions and billions of dollars have been going into trying to figure out how the planet's temperature was going to change, and we have failed miserably for 20 straight years. It's called the global warming pause. I do not trust any geoengineering plan beyond what it's going to do that day. Yeah, I have faith that they are capable of mitigating solar-induced heat on a given day or maybe the next day through the use of chemtrails. But that doesn't mean that it's not going to screw everything up much worse, or that it's not poison, or that it's not 100 other things that are terrible for us. And so, you asked, what do all these things mean for the planet Earth? And my answer to you is, I don't know, because I don't know what the idiots that live here are going to do. If we do nothing like our ancestors did, we've got a shot. Then again, you put any one of those ancestors, I don't care which part of the world they were from, out in the middle of nowhere today, and they're going to survive. Maybe 1 in 200, 500, 1,000 people alive today could say that.
Yeah.
But at least you'd have a chance. If we geoengineer the planet, we might not have a chance. We could end up making it so much worse. I happen to be of the mindset that the people who are doing geoengineering are the same people who are winning this economic game, and they don't want to stop playing because, frankly, if I can say so, they're kind of kicking our butts. And it's the same people that just keep winning year after year. They don't want this to end. They don't want the weather to change. And when you look at how the other planets and the sun are changing, you got to wonder how Earth hasn't changed more. I am of the belief that over this short term, they've done a good job keeping us from crapping our pants, going into chaos, creating anarchy. But I don't know how much damage they've done in the long term. Maybe it's already too much. So I can't answer your question very well.
That's okay. Matter of fact, you made me think of something here real quick. I used to live in Chicago. I lived there for 23 years. And there, and if I remember, the street name is Montrose Beach, used to have a jet ski port, if you want to call it, and people would back up their trailers with their jet skis, and it was just off the street. And they could back them in there, and they would jet out into the lake and have a good time. I was there just about 9 years ago. That jet ski port is still there, but the beach is now a quarter of a mile away. Now, I'm assuming, I'm not going to put this in, and I'm just using the word assuming. I know we shouldn't use the word assume, make an ass out of you and me, but being what it is. In western Michigan, there is a big company called Nestle who built a water purification plant which sells water to everywhere. Okay?
Yeah.
So they've been there since the 80s, and now I don't know, and I can't prove it, but I would assume that after, 20, 30 years of or more of being or pumping water out to bottle it and to sell it, I'm assuming that is actually has some sort of effect on Lake Michigan. I know that California is now talking about banning Nestle from pumping water from them because they're in that drought condition, as you talk about all the time. So, and now they're trying to move up into Oregon, which Oregon, I think, is going to start fighting against them. So I'm not going to say that everything is weather-related. I'm not going to discount it, but I would say part of it is just the people that want to privatize because of money.
Yeah, and that's the kind of thing where you put that right up there with deforestation. And when people talk about pollution, this, carbon, that, deforestation and the way we irresponsibly use resources and water should be mentioned in the same breath, although it never is, because it doesn't easily fit the propaganda lines like the carbon stuff does. Mm-hmm. But yeah, you're absolutely right. And the worst thing is, most people think like, when most people are going and buy a lot of bottled water, I'm not talking about like, they're thirsty when they're out on the jog in the city and they saw a stand and they stopped to get one. I'm talking about people who drink bottled water at home. Most of them do it because they don't trust their city water, or they don't want the fluoride that is in in a lot of the city water. Although some bottled waters are actually fluoridated as well. But so the interesting thing is that Nestle, and I believe this goes for Dasani as well. This stuff isn't spring water. It's essentially just tap water that they put into a bottle for you. And so not only are you not getting that clean, naturally filtered mountain spring water, and if it says, it's got to say spring water. If it says distilled or purified or drinking water, that's not the same thing. If they're getting it from a spring, they're also not stealing it from a natural reservation of water somewhere, at least upstream. Maybe they're having some effects downstream on where the water's going, but think about it. It's not like they're, stealing water from the mountain. This water is pouring out of the mountain anyway. The mountain is going to lose this water one way or the other. And so there the only effect is downstream rather than upstream. But I think that plays an enormous role in things too, especially in something called albedo, the planet's reflectivity. The day-to-day temperatures on this planet are so affected by the reflectivity of the surface or the clouds. It's unbelievable. I was listening to a couple of meteorologists discuss this maybe about a year and a half ago. But if you take a day, and I know you don't have much of this down in Mexico, but if you take a day in mid-March, say, and it's a snow-covered day in Columbus, Ohio, and it's 10 degrees outside or it's 15 degrees out there. It's kind of chilly for almost being spring. But there's snow on the ground, and that snow is white, and it perfectly reflects light. If there had been no snow on the ground, it could have been as warm as 20 degrees that day, with no other change but the fact that there was snow on the ground reflecting the light. It's not like the snow would cool things off anymore. At that point in the year, the ground is frozen. So having the snow there isn't actually what's cooling it off. It's the reflectivity of the land. Now, you want to talk about a lake, and you go from having water somewhere to having dirt somewhere, and that has very, very significant effects on the local climate. No doubt about it.
Oh yeah. I'm going to get back into some of these other questions. I want to see if we have anybody that wants to call in a little bit. But you were talking about, and this is just my mind probably just going far out and reaching for something. You're talking about hydrogen from the sun. And when you were talking about it in the video, the first thing that came to mind was hydrogen bomb. The first hydrogen bomb was exploded, I believe it was in the Solomon Islands or something out in the South Pacific, in either it was the late 40s or early 50s, and they found that the hydrogen bomb was more dangerous than a nuclear bomb, or the atom bomb as they used to call it back then. Is that a factor, something to possibly be concerned about with all of this hydrogen coming from the sun?
No, believe it or not, that's the breath of life right there. That's why we're all alive. And right after the mass extinction events, you have all this new, fresh star water on the planet. You get these explosions of life. What we do to create those explosions, where we actually unleash the energy held within the atom. That is something that I would almost say is impossible to take place naturally in our atmosphere like that. Then again, a solar flare on the sun can be the size of Jupiter, an explosion the size of Jupiter, and Earth itself fires gamma rays out of the top of lightning storms. And so, in terms of could there be something close to that mechanism going on, and could there be effects? Maybe. They'd have to be electrical, but it's not the kind of thing that you basically have nuclear bombs going off above our heads.
Mm-hmm. Okay.
Luckily.
Yes, definitely luckily in that case. I have one more question, and if there's anyone that's listening that wants to call in, you can call in now at 347-677-0812. Again, in U.S. and Canada, it's 347-677-0812. If you want to call in by Skype, go to our Blog Talk page and click on the Skype icon on the window and follow the prompts, and you can talk directly with Ben Davidson. Now, my last question here is, you're talking about, even in today's video, about the halo effect from explosions from the other side of the sun. And there always seems to be a lot of activity going on over there. Man, why is it so much activity on the other side of the sun and over on our side in respect to what's going on over there? Why is there so much activity on the other side versus our side?
Well, I have to tell you, I'm beginning to think that there are two separate universes being played out right now, because depending on who you ask, this is either the clearest, most obvious phenomenon you can see on the sun, or it is not happening at all. It's not happening at all seems to come from NASA and people like that, and the other stuff is coming from the people who watch the sun every day over at our channel and over at other channels as well. Essentially, I have not gone back through the entirety of this solar cycle yet, but from about the middle of 2013 to about the middle of 2014, there were, if you break the sun up into the Earth-facing fourth, the fourth that faces directly away, and then you have a fourth on either side facing left and right, in terms of the sphere. The Earth-facing fourth had 70% fewer CMEs leaving it than each of the other three each of the other three quadrants. Now, sometimes it was, the departing limb, sometimes it was the eastern limb, sometimes it was the exact backside of the sun. But regardless, the other sides are popping a lot more. When the Earth-facing side does pop, it is not hitting the level of flares that we have seen in previous cycles. It's not producing CMEs as often, definitely not as big when they are produced. And so this is what we call the Earth-facing solar quiet. And it's something that the Monders witnessed 400 years ago as we were entering the last grand minimum and basically capping off the mini ice age. And it's something that we're seeing again now in terms of why it takes place. There's a lot of interesting ideas. One that's fairly new was that all the electricity usage on the planet Earth is having effects up through our atmosphere and ionosphere and magnetosphere. And because our magnetic portal connects our magnetosphere to the sun, something about the use of electricity on this planet might be having something to do with that. I think it's a terrific idea, especially because it's electrical, and I like that. At the same time, we only have one portal connection to the sun. It is not to the sunspots, which is what I'm talking about right now with the weakening. It is always to a coronal hole. And sometimes our portal actually goes all the way over to the backside of the sun. And so I saw that a couple of times in comments that it's something we're doing in the atmosphere. Unfortunately, even if you can get past the power aspect, the notion that we could ever create enough energy to affect what's happening on the sun, which I don't think we can. There's the idea that the Earth is only connected at the coronal hole, and sometimes it's not even connected to the Earth-facing fourth at all. And so we really don't have very much of a good explanation at all. There have been a ton of what I would consider crazy ideas, including one of my own, which I choose not to share very often because it makes me think I need a straitjacket. But there's just no good explanation for this. It is just following the Earth. It has been following the Earth since November of 2011. No other planets seem to have this effect. No other planets seem to be spared like the Earth is spared. And that, the fact that it's inexplicable might be the reason why folks at NASA say it's not happening, because they don't want to, say it's happening, but we don't know why.
It's all right. You just answered another question I forgot to ask anyway. But we do have a caller coming in from Washington State. So, Washington State, you're on the air with us. What's your first name?
Marty.
Hello, Marty. How are you? Do you have a question for? Good.
Yeah.
Do you have a question?
Yeah,
for
Ben.
me?
I've been watching your morning releases as often as I can, and looking at the images of the surface of the sun with the various filaments kind of moving around and erupting. I'm curious as to how close that is to real time. Is that time lapse? Is that sped up or slowed down?
Yeah, it's very much sped up. Most of the time, unless I have cropped the image because I want to zoom in on something specific, most of the time you'll see the timestamp actually in the bottom left corner when the sun is on the screen. Like I said, not all the time, but at least once, I would say, in just about every video. It's been a little bit more difficult because HelioViewer has been down the last 3 days. But yeah, so what you're normally seeing is either 12, 24, or 48 hours sped up to either 5, 10, or 20 seconds. And, it's really, I don't really give any indication of that while it's on screen. You pretty much just got to look at the timestamp, which is normally, like I said, down in the bottom left corner. Of course, it hasn't been the case the last couple of days because we don't have HelioViewer, but if you pull up one of the news videos from last week or something, and you look down in the bottom left, just during shots of our start to close, you should see that timestamp, and it'll give you a pretty good idea of how much time is elapsing during those sequences of the sun that we're seeing.
Yeah, some of those snaps that happen rather suddenly. So I was just trying to get some sense as if that's happening in real time, or that might take place over a maybe a 2 or 3 hour period.
Oh, absolutely. Some of these filaments, I will see them destabilizing before I go to bed, and in the morning news, they're still not gone yet. Then again, we have seen what are referred to as impulsive flare events or impulsive filament eruptions that last, just 15 to 20 minutes, maybe 30 minutes, and then the event is over. And so it's I'd like to say that there's just a blanket rule I can give you, put it in your pocket, that's the way it's going to go. Unfortunately, it's really much more of a pragmatic look at every situation and see how it's going to happen, see how long it takes. The longer that you see a solar flare active for, the bigger the eruption is going to be in general. But I feel like that's also obvious.
The speed of the sunspots across the disk, is that relevant to say one rotation of the sun on its axis, or one half a rotation?
It's supposed to be about, the sunspots are supposed to move approximately with the surface of the sun. I've been looking at it quite a bit, and it seems to me that the sunspots move a little faster than the rest of the sun. And, of course, the sun doesn't spin at the same rate everywhere either. If you're standing just outside of the polar region of the sun, it'll take almost a whole month for you to do a rotation. Then again, if you're standing at the equator, it'll take you less than 28 days to do it. And so, there's that 3 or 4 day between the equator and the poles. And, the sunspots, they're moving around close enough to that for all intents and purposes and for everything we're practically going to need it for in the short term, yes, essentially the sunspots move pretty much with the surface of the sun, although I tend to notice them moving a little bit quickly, or a little bit more quickly.
What is the cycle for one rotation?
What do you mean? Like how many times?
How many days? How many days does it take? Of our days, does it take for the sun to make one rotation on its axis?
Generally 28.
Oh, 28 days. Okay.
So it'll be 14 days on our side, 14 days on the back side. But like I said, if you're on the equator, it is actually a little closer to only 27 days for a rotation. And if you're up near the poles of the sun, it's actually closer to 30 days for a rotation. So
Ben, can I interject something here real quick?
Sure.
Most of the ancient calendars that I've ever seen are normally 28-day cycles for a month.
Yeah,
that helps anything.
Mhm.
Interesting.
Well, yeah.
One other quick question. You use the term referring to the disk as a limb. What does that mean?
It basically just means the side. I have no idea why heliophysicists chose that word, but essentially the limb is the side of the sun. And so the incoming limb is where we see sunspots crest into view, and then they face Earth for a couple of days, and then they turn away on the departing limb. And it's, L-I-M-B, just like your arms hanging at either side of the sun, which I guess would be, I'm hoping that is somewhat related to why they made the decision. I don't know. I wasn't in the room when they picked that word, but yeah, that is what the limb is. It is the sides of the sun that are visible from Earth's point of view.
I see. Well, thank you very much. You've helped a lot. I enjoy watching or listening to your show.
Pleasure.
Well, thank you, Marty, for calling in. Yeah. Anyway, that was some good questions there.
Yeah, he did have a couple good questions.
All right, we only have a few minutes, so let me just open the mic. We only have maybe about 5 minutes, so then I'm going to leave the mic open for you for 5 minutes, whatever you want to address.
Sure. Well, given the fact that the topic the initially contemplated topic for today was climate change and how that might affect us. Let me focus a little bit on that with just some high-level points. For all the observers listening, this will be a bit of a review, or if you're brand new, time to get on the same page as everybody else. When you hear about the dangers of climate change, you hear about how global warming is going to cause storms and droughts and floods and all this other stuff. But you don't hear about what the dangers are from actual heat. What is the actual danger from warming, apart from all the things it can allegedly cause? And the answer is none. The real effect of a warmer planet in terms of temperature is you have more farmland in Siberia and Canada, and we don't have to rely so much on Monsanto's poisonous GMO crap. However, the floods, the droughts, and the crazy storms are also what was discussed by our ancestors, and they weren't exactly polluting on a catastrophic scale. And we tend to see this activity on the other planets as well. Whether it's the winds, the temperature, or the storm activity, Venus, Mars, the Sun, Jupiter, Saturn, and Uranus are all changing faster and to a greater degree than Earth is. And that's even considering, something relative. If you're thinking in your head, well, obviously some kind of change on the Sun or on Jupiter would be bigger than that of Earth, obviously. Well, I'm talking about relative. So, for example, a 6-foot guy gains 6 inches. It's relative to a 5-foot guy gaining, 3 or 4 inches. So you know what I'm saying? It's all relative. And even when you make everything relative, the Earth is doing better than every other planet in the solar system, which, again, I'll mention, I think, is because those people who are winning this economic game don't want it to stop, and they're actually paying to have the planet changed and so that they can keep winning and basically keep their greed going. But the point I'm making is that everything that is being blamed on global warming can also happen with a sharp energy change in our solar system. And we saw this happen hundreds of years ago. We know that from our ice core data and some of the other data that we do have. We know it happened before that because our ancestors discussed it. And we know it's happening all throughout the solar system because we can see it right now. And so we have to at least look into the possibility that we should stop polluting the planet so much and consider whether or not there are other things that affect the climate other than your car. And unfortunately, there's $30 billion that will be spent in 2015 either studying, planning for, or otherwise going to climate change this or that, and not one single cent has anything to do with cold events, ice events, snow events. More people have died in the United States from cold and snow events than from every other natural disaster put together for the past, back until we got, our last major tornado outbreaks. And in fact, tornado outbreaks are the only thing that kills more people in this part of the world than snow and ice. And so, yes, we have these terrible storms all across the planet. We have droughts, we have floods, but we also have these cold events. And the thing with global warming is, you haven't heard it recently because they wouldn't be so dumb as to keep saying these things, but it wasn't that long ago when it was pretty much well accepted or in the mainstream news that snow and ice were about to be a thing of the past. Well, we keep seeing snow records falling, cold records falling, and even if that wasn't the case, we get hail and snow at the equator sometimes. So it's not like hail and snow is going to be a thing of the past. And to spend $0 of your $30 billion climate change budget worrying about those events, it's insane. And unfortunately, because of the propaganda and the money to be made in this climate change game, we have almost no shot of them ever coming around and including what could be the most important aspect of climate change. Whoopee, we spent 350 days this year, 0.4 degrees Celsius above normal, and we spent the other 15 days 20 to 30 degrees below normal and under 4 feet of snow. Well, the global warming lines don't really help you in that case, and that unfortunately is what we are seeing. The world, most different places in the world spend 80 to 90% of their year slightly above average, and then when they get their cold snaps, it's absurd. And that's what's going to keep happening. That's what's going to exacerbate. That's the big problem with climate change.
Ben, we're going to have you back again soon. So if you can, let me know when you can come on, like in 6 weeks, and we'll continue the show, because I got some other questions I'd love to ask you, and I know you'd have a ball answering them. But
Absolutely.
At this point, we do have to end the show, and I'm very grateful that you came back to do another show with me. And let's see what we can do, and if we can, let's get on Skype after the call, and we'll talk some more. But anyway, we have to end the show. Thanks, everyone, for being here, and thanks for calling in, and we'll talk to you again soon. Take care, and be well.
Thank you for joining us for today's show. We hope you found today's show interesting and of value to your life. Please visit our website at www.kwave6radio.tk. That's www.kwave6radio.tk. Follow our blog titled What's New for all upcoming shows and events. You can follow us easily by clicking the RSS feed icon on the blog page or via Twitter and our Facebook page. Also, visit the Freedom Talk Radio Network and SETV site at www.freedomtalkradio.co.uk for more interesting programming. All of the K-Wave 6 radio programs are archived on our YouTube channel. See our homepage for more information. As always, all the best.